Hi, we're Team Phantom Vanguards. For this hackathon, we built DevScope, a high performance search engine for source code and logs. But here's the thing, we didn't use Lucene, ElasticSearch, or SQLite. We wrote everything from scratch: binary file formats, our tokenizer, and a ranking algorithm. Let us show you how it works. Okay, so let me just build the executable and then I'll show the indexing. First, we index our entire project directory. DevScope crawls every file, tokenizes the content, and writes a custom binary index to .devscope. Notice the speed, 22 files in just 36 milliseconds. That's the power of Go's low-level input-output. Now, let's search something. Let's say main. Notice the ranking. Main.go appears first, even though sample documentation mentions main more times. Why? Because a ranking algorithm gives a +5 bonus if the search term appears in the file name. Developers usually want definitions, not documentation. DevScope understands logs. I can search for timeout but strictly filter for level error. It ignores warnings or info logs, showing me exactly what crashed the server. This is our most complex feature, phrase search. When we wrap terms in quotes, the engine doesn't just find files with both words, it verifies they appear right next to each other. Match.txt contains hello world in sequence, so it matches. Phrase fail has hello big world. The words exist, but they are not adjacent, so it's correctly excluded. What you're seeing here is not random bytes. This is our custom posting list format, similar to how Lucene works internally. Because every field has a fixed layout, we can jump directly to a term's data using byte offsets. That's why DevScope doesn't scan files, it seeks. We designed our own binary format. No JSON, no SQLite overhead. Every posting is packed as raw bytes. 4 bytes for doc ID, 4 bytes for frequency, 1 byte for metadata flags, and end positions as 4-byte integers. This compact structure lets us seek directly to any term's data without reading the whole file. Our tokenizer is context aware. Look at line 49. We use a regex to detect function definitions like funcmain or devprocess. If a word matches the function name, we set a metadata flag like in line 60. Later, our ranking algorithm uses this flag to boost the score by 3 points. This is how DevScope understands that a definition is more important than a reference. This is the brain of phrase search. Here's the algorithm. First, we start with all the positions of the first word. Then, for each subsequent word, we check does any position equal the previous position plus 1. If yes, it's a valid chain. If no, no chain survive, the phrase doesn't exist in that document. This is called positional intersection and it's how real search engines like Google handle code queries. Our ranking uses a classic TF-IDF formula. Line 45 calculates IDF, the logarithm of the total documents divided by the documents containing the term. But we go further. Lines 155 to 160 add contextual bonuses. This hybrid approach combines math with code-specific heuristics. To summarize, DevScope is a from-scratch search engine with custom binary index files, context-aware tokenization, TF-IDF ranking with metadata bonuses, exact phrase matching using positional intersection. If we had more time, we'd add delta compression to shrink the index and concurrent crawling for even faster indexing. Thank you for watching. Hope this demonstrates that you can build production grade infrastructure without relying on frameworks as well.